Sam. I am Pete Hasbrook. I work in Houston at the International Space Station Program Office. I'm an Increment Manager, and I'm going to take a moment to tell you what that means because I think it may help you understand some of the rest of the presentation. As we are planning the ISS and its life and its mission that's over years and years, we have to break up our planning. And we do that based on Soyuz crew rotations. So every time we have a Soyuz depart, we get a new crew commander. For another 2 months or another 4 months, we break that up into a sub-mission, and we call that an increment. Nothing special about the name other than, just like the integer. But I then am an increment manager, so you can think of that maybe as a mission manager. And part of my role is to integrate from across the NASA organization as well as across the partners, bringing in requirements, prioritizing those, explaining those to the rest of the partners, and agreeing on what the plan is going to be. So in my role as an increment manager and an integrator in the station program, I've started to help with the exploration program based in Houston. And I'm here to tell you about our ISTAR program, or using the ISS as a test bed for analog research. Let's see, green means that way, great. Charlie talked a little bit this morning about how we're continuing the ISS. We are continuing the partnership with our international partners. Our mission statement for the ISS includes exploration. Basically, as Charlie said and Sam said, we are about finished with assembling the International Space Station. We've got about all of the elements up there. There's one more major Russian element coming about 1.5 years. But basically, we're finishing the outfitting of the internal modules, and we're stepping to the next phase, which is full utilization of the station. Full use of its research capabilities, of its resources that we have on board. And again, as Charlie said, and as I just said, that's not just the space station goal, that's the NASA goal, to further exploration through use of the space station. So the project I'm here to tell you about is a cooperative effort between the station program to be used as a test bed and our exploration program, again, based at JSC, my counterparts. And we've put together a cooperative effort that we call ISTAR, using ISS as a test bed for analog research. We have an IPT, or an integrated product team, that's put together. I am one of the co-chairs, I on the ISS side, and I have a counterpart on the exploration side. We've brought together people from the Exploration Mission Systems Office, the Analogs Directorate, and maybe a lot of you know this, but think analogy, think of something similar. You're testing something in an environment or a system that is similar that you think your final environment will be. So we have an Exploration Analogs Mission Office through the station, or not through the NASA program. We've got the Human Research Program. Dr. John Charles talked about that this morning. We've got people from Mission Operations Directorate, the Crew Office, from Engineering at JSC, as well as Public Affairs and some other organizations. We are in the phase now of defining what we call Exploration Detailed Test Objectives, or XDTOs, and I'm going to use that term quite a bit as well. We're looking at categories of XDTOs. We're kind of parsing up what's been suggested so far, and they're falling into areas of behavioral health primarily, as well as the crew's overall physiological, medical, mental health. We've got mission planning and execution. We know we're going to need to do things differently as we go to Mars or an asteroid. We're starting to bring in some of those theories and philosophies, and we're going to start testing those. Technology demonstration, of course. We've got the ISS in orbit. Can we use it to investigate the systems that we want to test? So the ISS is going to be, as a platform, an analog, but it's going to be a complement to analogs that we already use. You probably have heard of Desert Rats, the Nemo underwater environment off the coast of Florida. We also have other ISS assets on the ground. We've got the space station training facility where we do our simulations with the crew and mission control. We've got the neutral buoyancy lab, which may allow some asteroid practice or the Martian surface practice. So in some cases, these tests or these theories or these XDTOs have been tested on an analog already. For instance, a communications delay has been tested in Desert Rats. And now ISS is kind of the next logical step to step up in fidelity to go test that. A little bit about the process that we're using to identify and then vet and then select the XDTOs. The exploration program will look through there and their projections, and for reference, the design reference mission from this morning. What are the risks that they see to developing the program, to meeting their mission goals. What are the risks that they think they're going to have to overcome? Maybe in life support systems, it may be in operations, it may be in the crew health, behavioral, physical again. It may be in the mission control side, in the planning and the execution, in training crews. How do you train somebody to be on their own effectively for those 6 months or for that long time? We then will identify the station or the exploration program, will think of an ops concept or think of a design concept, and then they'll pick a way that they want to test that in our analogy. They will then look through the resources that they think they will need from the space station program. We have limited resources both on the ground and in orbit. The crew time to do something on orbit, what we call upmass, launching hardware to orbit and stowing it on the station. We also look at when is something funded, is it going to be ready in a time frame that we want to put it on the station? What schedule should it be working to? With the iStar IPT, we then look at that list. We have created a method to evaluate them, to kind of rank them, to show how ready they are. The IPT, or the exploration program, will then propose to the IPT a list to be considered for each increment. And each increment, again, is the 2 or 4 month period that I'm a manager of. Exploration program will then forward that to the space station program on our side. And we will work that list and evaluate that through our utilization process. I'll go through a little bit more of that in a minute here. But basically we NASA are treating these NASA proposals under our NASA allocations as part of the partnership. We don't get all the crew time that we have on orbit, for instance. We don't get all the upmass that we have. We have percentages that we've worked out over the years with the partners. So currently we are looking at how to take all these proposals and fold them in with existing proposals, as Dr. Jeanne just mentioned to you. Kind of a high-level description of the utilization process. It's not my primary job, so I'm maybe a question deep, but the good news is I have some friends here who ought to be several questions deep. But basically, as we're looking ahead to increment planning, we want to put together a research plan for that increment, for that 2 months or 4 months or 6 month period. And I'll say 6 months, a crew member is on the station for about 6 months. Even though during that time there are Soyuz coming and going, so they are part of 2 different increments, that crew member is on space station for 6 months. So there are some specific tests that are targeted at the length of a crew's occupation on the station. So we want to put together an increment plan, and the process kicks off about 18 months before the start of the increment. We bring together the requests, we understand the resources that are needed, we understand the objectives that are behind the science, we understand how ready those are. We throw all those together, and through the magic management of the research planning working group, they pull together a list of what we think we can accomplish in that 2 months or 4 months or 6 months. Are there investigations that would complement each other? This is a multilateral forum, so let's say the Europeans have proposed something that requires blood draws of the crew. If there's something on the NASA side that also requires blood draws, can we take a common blood draw and share the data between the two? So we try to make most effective use out of what's being proposed and the resources that we have. And that takes about 6 months total. So from the start of an increment, we just started one in March. We were starting this increment, or the integration process, 18 months before that. So September of, must have been 2009. So how are we integrating XDTOs into that, the exploration tests that we're doing? Basically, as I said, the utilization office receives the list, the proposed list from the IPT, from the exploration program, and we have to review those, and we start then to prioritize those into the science that we've already had in the pipeline for a long time. We will again look for complementary investigations. We will look at priorities that come to us from headquarters basically, but also influenced by the government, the industry. And then through the multilateral research planning working group, they will put together the proposal for the increment plan. That gets reviewed and approved through the multilateral payloads control board, which is our station program utilization office. Again, we are integrating not just the NASA proposals, but also the U.S. operating segment international partners. So that's Europe, Japan, and Canada. The Russians are the 5th partner, or the first partner if you're talking to them, in the International Station Program. They have separate methods. As we, just to put a time frame on where we are, we're going through this new XDTO process right now. We've been working, the concept started, as John's charts showed, since about September of last year, to start putting the IPT together, decide how we're going to round up all these proposals, bring them into a flow. So we're about 6 months into that. We've used an accelerated program to look to the increments that are a year from now, the increments that are starting in March of 2012 through September of 2012. Those are 12 months from now, so they've already finished their increment research plan, and now we're having to merge in the XDTO request into that. Beyond that, we're going to start using the nominal process now, about the 18-month build, understand, build up to the plan for September 2012 through March of 2013, and that's increments 33 and 34. I mentioned that we integrate all of our work with the partners. So far, we are only proposing NASA XDTOs, NASA proposals, but we realize that some of the proposals are going to require either the cooperation of the partners or perhaps the participation of the partners. And I kind of differentiate those. If you're cooperating with us, I kind of think of it as, please put up with us while we do our investigation that may impact your operations. Participation may be, we'd like your crew member, we'd like your program to be a participant as perhaps an investigator or contribute resources on your side. Some of the reasons that we are going to need partner participation, behavioral is a big one. That's actually probably what started this whole thing, is how is the crew when they're on a transit mission and they're isolated, how are they going to react? What's the environment going to be like for them? And especially with the communication situation that we have, the comm delay as we call it. If at some point on your outbound route, it basically means there's no point in talking anymore because you're waiting so long to hear what the answer was, you forgot what you asked in the first place. So we're putting together some scenarios where we would delay communication and see and force ourselves to learn how we would operate. But if you're doing that, the station is built as it is. And Trey's going to talk more about operating the space station, but it takes a lot of care and feeding from the ground. A lot of the activities that we do require real-time communication with the station. So things like docking a vehicle has to be over the ground sites, has to have real-time communication, similar with a spacewalk or an EVA. So if we're trying to get the environment, the behavioral environment, in a comm delay, we're going to be asking the partners to take those high visibility or those high activities out of our week-long period. Some other reasons that we may need the partners. Our control centers are very integrated. Again, as Trey will tell you, we share data, we share plans hour by hour with our partners. And so if we're going to be delaying communications on our side and affecting the planning, we need our partners to be aware of that, participating in that. And finally, John mentioned Don Pettit, who flew on Expedition 6 and the Soyuz landing that did the landing in the middle of nowhere in Kazakhstan. If we were to try to plan something like that, we will need participation and cooperation, especially from the Russian partner. Whether it means we want to have the crew get out of the vehicle and do something in situ in Kazakhstan, or as part of our return, we don't bring them to Houston, we send them directly to Arizona to Desert Rats. There are some concepts out there for that kind of thing. If we were to do that, we would need a lot of coordination with our partners. We've initiated those discussions with the partners as part of the Space Station Control Board. Our program manager, Mike Safardini, and his counterparts. I gave that presentation last month, and the reaction was positive. There's interest in that. They're thinking about that now, and we're starting to have them think about what they might propose to now integrate in with the NASA program. One of the most items of interest is comm delay. You all have talked about that among yourselves in some of the paper or the presentations today. But we see that as one of the big operational challenges and one of the challenges in behavioral health of the crew, of not being able to communicate immediately. So we are starting to, and when I say we, it's primarily John's folks in the Human Research Program, to develop the concepts for what we would want to do and why we would need to delay communications in a simulation on the ISS. Our first targeted look is for next summer, between, I'll just throw out maybe June to September, somewhere out there. We would pick a week is the concept, 5 to 7 days, take a typical week in the life of ISS. We would figure out how to delay information exchange to and from the crew. Again, there's kind of two targets here. One is the crew behavioral health, the other is the operations, the planning and the execution by the crew. There are some people that would like to delay the commanding and the data just to get a better simulation so that the crew has to actually wait for the ground to do something instead of having it done immediately. That would be probably quite costly as we're looking at it, to put something into the system to delay the commanding, delay the voice. There's a lot of work to be worked out on that, and we're just starting to get into some operations panels to start understanding that. Again, we're going to recommend that all the partners participate or at least cooperate or put up with us. If we're going to pick a week, we want to pick a week where they'll agree to not launch a vehicle during that time frame. As part of this work, we're looking farther ahead, years ahead. We're starting to look at how we would make these more challenging. Longer weeks, longer months that we would do this, increasing delays and more complexity. So as we're starting to implement this, the current increment is increment 27. That was Paulo and Katie. They gave you the greeting this morning. We are not trying to change anything that those teams are doing. There's a lot of work that goes into planning the increments, to setting up the requirements, to getting the mass to orbit. But what we are doing is we're starting off by looking what is in the plan and where are some areas that our exploration friends could get some benefit by knowing what's the investigation going on the ISS, sharing the data. 6 months from now, the increments that I will manage, 29 and 30, we are pretty much through our requirements definition phase. Now we're going to turn those into plans. So it's a little bit easier to add an investigator, to add some questionnaires, to get a little more influence into the data. A year from now, March of 2012, is increment 31 and then 32. That's the accelerated process that I talked about. I have another chart coming up on that. And then finally, September 2012 would be the normal cycle for our IPT work. And in my hot off the press department, this is last Friday before I came down here, the exploration program finished its work, our first round of the requests for use in the station as a test bed. And they've chosen 5, they've prioritized 5 in there and forwarded them to us on the ISS side. I've got them listed here. I have just a little bit of information about each one of them. But basically, number 1 on the list is the COM delay, as I've just described, the 1-week version. The requirements on that are still definitely in work. The second one from our JSC engineering organization is a proposal to take advantage of some of the alpha magnetic spectrometer data. The AMS is being launched on the next shuttle flight at the end of this month. An active shielding proof of concept. AMS is going to generate a magnetic field. The investigators of this test here would like to see the data if there's a solar proton event, an SPE. What is the AMS taking data-wise? How does that particle behave in the AMS's magnetic field? It'll tell us something about being able maybe to use active radiation shielding on the next vehicle. The next one is, number 3, is to use spheres, which is the synchronized position hold experiment. It's a little bowling ball-sized experiments, little mini satellites, if you will. Those are developed by MIT, and they're mostly have been used to test formation flying. But there's a desire to be able to image or to take imagery of the outside of the space station or the outside of a vehicle that's on its way to Mars or an asteroid. So the investigators want to add a camera to one of these guys and have the crew control it and see if the crew could control and take imagery and do an investigation. Is there micrometeoric debris, little hits out there? Basically, not have to go outside and do an inspection. Number 4 is to use Robonaut. I bet everybody's heard of Robonaut. The title, it takes a little bit of reading to understand what the title means here, but it's a 2-parter. One is they want to use the Robonaut to simulate an EVA routine, and basically it's to take one of our orbit replaceable units, like an electronics box, and use the remote tool, the grabber on it, also use a pistol grip EVA tool, and just demonstrate that Robonaut could actually do EVA tasks, whether it's autonomous or under the control of a crew member. The emergency operations part of it is to take a fire extinguisher, have the Robonaut take a fire extinguisher, demonstrate that it can handle it, for one thing, potentially discharge that into a mock rack. If we had a fire on the station and it was a hazardous situation, you may not want to send the crew in there, but you could send a robot in to do something like that. And the last one on the list is from our Mission Operations Directorate, Crew Autonomous Planning and Execution. Basically, our timelines, as Trey will talk about, are set. We build those on the ground for the crew, but from a crew that's outbound or homebound from a Mars or a near-Earth object, they would do a lot of their own planning. They would be more autonomous, so we want to test some of those systems. There's two parts to this. They would take the existing timeline and allow the crew to rearrange it as they saw fit. We would give the crew some tools to be able to do that, knowing the constraints a little more intelligently. And then the next step on that would be to give the crew a blank day with a list of things and have them pick the order that they want to do things. Again, the tools would tell them the constraints. This has to be over communications or in daylight, or you can't do this at the same time as something else. So the station program is now going to evaluate this list. Our utilization office has started to do that. We will get back to the IPT and the exploration program at the end of the month. So basically that's an overview of the I-STAR mission, where we're wanting to use the station, actually really use the station as a test bed for NLF research. And I'll save questions for the end. Thank you.